So simplistically, we say you have two types of electrical circuits. We say that there is series, and we say that is parallel. And these two have different characteristics. So a series circuit will look something like this. So that's your battery, your DC, your DC power source, and your current will flow like this. And we're saying that that's, components are in series. Or you can have things in parallel, so something that looks like this. And so these are things in parallel. Now, if things are in series, then the current for each component is the same. The resistance of the circuit is equal to, adding up the resistances. And the voltage drop across the circuit is equal to adding up all the voltage drops as well. And the key thing about having sort of a series, the key thing about having a series circuit is that there is only one path. So you can see that the current goes from, let me just get spotlight. So you can see that once the current starts here, it just goes across through here and back around. And there is no other pathway for the circuit to go. And now you've got a parallel circuit, and a parallel circuit is different to a series circuit in the sense that, well, the path the current takes, once it goes through one component, it doesn't mean it has to go through the second one. So you can see it can go through this light bulb without going through this light bulb. And so we say that this is a parallel circuit, or more accurately, that the two light bulbs are in parallel with each other rather than in series with each other.
Yeah.
And if we say that, then we need to use the formulas for parallel circuits to do this calculation. And so the resistance, the resistance of the circuit is not R1 plus R2, but rather we work out, it's easier to rewrite the formula as 1 over the resistance of the circuit equals 1 over R1 plus 1 over R2. We'll note that the voltage is the same.
Yeah.
And that the current of the circuit is equal to the sum of the currents.
Okay.
So basically, you need to work out whether you've got a series or parallel circuit. And once you work out if you have a series or parallel circuit, and again, more specifically, whether the components are in series or parallel, then you can use the appropriate formulas.
Yeah.
And these formulas kind of make sense if you think about sort of what they mean, right? If you understand that a voltage is a voltage drop, a drop in, potential electrical voltage. And if you think about your voltage drop, then your first component drops at the voltage V1, your second component drops at voltage V2. And if you have to go in series, then V1 plus V2 is the total voltage drop of the circuit. I'll try and stay away a little from sort of those sort of conceptual things because I know you're more worried about doing the actual calculations for the moment, in which case you can probably just focus on the rules and the formulas. but these rules do sort of make sense. Same thing here. If you've got current flowing through the whole thing and there's no other path, then the current is the same throughout all the components.
Yeah.
Over here, the voltage is applied to the left and the right of this bulb because the voltage comes from this battery. So the voltage of this light bulb is directly from this battery, but the voltage from this light bulb also is directly from the battery because the voltage gets to be applied to both ends of the light bulb without any sort of voltage drop. That's why the voltage is the same. And the current, well, if you're going to get some current passing through here and some current passing through here, but then they all join back up here, then the current, electrical current, is therefore the sum of the currents.
Yeah.
So we'll do some simple examples first to give you the idea. So if we have a circuit like this, is this series or parallel?
Series.
And if I say I have a 24-volt battery, then, and I tell you that the resistance of this is 3 ohms, and the resistance of this is 5 ohms, then because it's a series circuit, what is the resistance of the circuit?
Oh, is it 8?
So it's 5 plus 3 because it's series. So it's 8
Yeah, 8
ohms is the resistance of the circuit. Now, we know the voltage of the circuit is 24 volts, right?
Yeah.
We know the resistance is 24 volts, right? We know the resistance is 8 ohms, right?
Yeah.
So how do we work out the current of the circuit?
The current is it I equal V I equal V over R.
Yeah, so we'll use Ohm's law. So Ohm's law is a law that applies to, I guess, you know, resistors and things that follow Ohm's law, which basically says V equals IR.
Is it like I mean is it I times sum of I divided by wait I mean is it V over sum of resistance?
Well, it's simply V equals IR for Ohm's law for the, you know, for the right voltage, for the right current, and for the right R. And so in this case, we're looking at the voltage of, we're looking at the circuit as a whole. So it's the voltage of the circuit and the resistance of the circuit.
Yeah.
So we know the voltage of the circuit is 24. We know the resistance of the circuit is 8. The fact it's 5 plus 3 is not important. The fact is, if I ask you what the resistance of the circuit is, it's 8. Once you work it out, it's 8. And therefore, as far as the circuit is concerned, the current of the circuit would therefore be 24 over 8, which will give you 3 amps.
Yeah.
So at this point, what we're saying is that for the circuit, we have a voltage of 24, we have a resistance of 8, and we have a current of 3 amps. Does that make sense?
Yeah.
All right, then. We'll then go and do a simple example of in parallel. Well, in parallel. So if I have an example of something like this, and let's again say that this is in 24 volts. And just to make the numbers perhaps a little bit nicer, let's make this 4 ohms and 6 ohms. So for the circuit, what's the voltage?
The the voltage is 24 V.
All right. Now, what type of circuit is this? Is it series or parallel?
Parallel.
So therefore, how do I work out the resistance of the circuit?
1 over so 1 over R1 plus 1 over R2.
I do need to work
Wh-
out 1 over R1 plus 1 over R2, but that equals what?
Which equals a quarter plus 1 over 6.
Sure. And what does that give you?
Wait. Calculate. It's
So once you add it
5
together,
over 5 over 12.
yeah, you get 5 over 12. And then what's the resistance of the circuit?
So resistance is
So the resistance of the circuit is 12 over 5.
oh yeah.
Or if you like, 2.4 ohms. And the reason I say that, of course, is I'm really stressing the fact that, remember, you do need to work out what 1 over R1 plus 1 over R2 is, but that is not the resistance of the circuit. It's 1 over the resistance of the circuit.
Yeah.
Which means once you work that out, you still need to, well, basically take the reciprocal.
Okay.
Does that make sense?
Yeah.
Okay. So now we've got the voltage, we've got the resistance of the circuit. What's the current of the circuit?
Current. Where I equal 3 over R. So is it 24 over 12 over 5.
It is. And what will that give you?
Oh, because I don't have calculator, so
It'll be 10 amps.
oh, okay.
So therefore, you'll end up with, you've now worked out the voltage, the resistance, and the current of the circuit, yes?
Yeah.
Now, what I want to also show you is these things that we're talking about are all consistent with each other. So I've done it sort of at the sort of circuit level, right? Where I've said, okay, if I look at the circuit as a whole, I know its voltage, I can work out the resistance using the laws, I can work out the current, and now I've got the voltage, the resistance, and the current of the circuit, right?
Yeah.
But now, let me consider light bulb A and light bulb B, all right? So
Yeah.
light bulb A, what is the current going through light bulb A?
3.
Yeah, because we said in a series circuit, there's 3 amps going through the whole thing, which means there's 3 amps going through light bulb A.
Yeah.
Now, do we know the resistance of light bulb A?
Wait, for oh yeah,
What is
5.
it? So can we work out the voltage drop across light bulb A?
Equals equal 15 15 volts.
So it equals V times I. V equals IR. And that would just be 3 times 5. And as you said, that's just 15 volts. So now we've worked out for A, it's got a resistance of 5, a current of 3, and a drop of voltage in 15 volts, right? Let's do the same thing for B. What's the current for B?
Oh, B. So it's what? Oh, it's the same 3.
What's the resistance?
3 as well.
What's the voltage?
3. 9.
So can you see, firstly, that we can work out the current, resistance, and voltage of each individual component and not just the circuit?
Yeah.
Can you see that V equals IR applies both for the components that are ohmic, so A and B, as well as your circuit as a whole?
Yeah.
And can you see that what we're saying is sort of true? So for example, 5 plus 3 is 8, which matches that law that we said for a series circuit. And check out the voltage. 15 plus 9 is?
15 plus 24.
Yeah. So you can see that the voltage drops are the sum as well. And check out the current,
yeah.
right? The current for the circuit is?
3.
And for A and B, it's?
3.
So really, we're just showing you that these sort of concepts are correct. The current for all components are the same in a series circuit. If you're trying to work out the resistance, you're adding up the resistances of the components together. The voltage of the circuit is equal to the sum of the voltage drops across the components.
Yeah.
And we'll do the same thing with the parallel circuit. So the parallel circuit, let's call this A and let's call this B. So we've worked out the circuit's resistance and voltage and current. Let's look at A. All right, so for A, what is its resistance?
A's resistance is 4.
Now, are you able to tell me the voltage across A?
Voltage 24.
Yep, just because, the battery is more or less directly connected to A, right? So you're right, the voltage across A is 24 volts. And therefore, what's the current?
And therefore, the current equals 6 amps.
And for B, start with resistance.
For B is 6 ohms.
What's the voltage?
Voltage is the same.
And the current?
The current is 4.
All right, so again, we can work out both the voltage, the current, and the resistance of each component, right?
Yeah.
And since we can work out the voltage, current, and resistance of each individual component, then you'll see that the rules we said earlier match up. So the voltage is 24 across the circuit, it's 24 across A, it's 24 across B. So the voltage across all components are equal in parallel.
Yeah.
Well, the resistance, we worked it out using the numbers. So the resistance of the circuit is 5/12, the resistance of A is 4, the resistance of B is 6. And so, they match this formula, I guess, because we worked it out that way. But you can see that the current is, it makes sense, right? A has 6 amps flowing through it, B has 4 amps flowing through it, and so the current has 10 amps flowing through it. And that hopefully makes sense because if you recognize that down this pathway, you have 6 amps flowing through, and down this pathway, you've got 4 amps flowing through, which will go through B and come back up. That means when the 6 amp and the 4 amps join together, from here on, there'll be 10 amps flowing through there. Right? The 6 amps and the 4 amps will join together to get 10. Or alternatively, the 10 amps will come down here, and then 6 amps will split off to the right, and 4 amps will split off downward.
So we'll parallelize add them together.
Yeah, well, it depends, you know, if you're looking at this point compared to the separate paths, then yeah. Think of it like a crowd moving, right? If you've got a, you know, or water, right? Either way, if you've got 10 people, 6 of them can go this way and 4 of them can go this way. But when they rejoin, there's still 10 people, right?
Yeah.
Yeah. All right, so that's basically the basic idea behind how you do these circuit calculations. So you need to work out if you've got a series circuit or a parallel circuit, and then, you know, use the formulas or use these sort of concepts if there's no numbers given. But even if the question doesn't ask you to work it out, while you're practicing, I want you to work out the voltage, the resistance, and the current for each component if you can. Does that make sense?
Yeah.
Now, do you have any questions about these series and parallel circuits right now?
No, I think.
All right.
No.
So now I'm going to give you another example, okay?
Yeah.
Now, let's say so I'm going to call this A, B, C. I'm going to say that, you know, for simplicity, I'll say B has a resistance of 6 ohms. I'll say C has a resistance of 4 ohms. And I'll say that this has a voltage of 36 volts. All right, so I make up this question, all right? You can read everything?
Yes.
Okay, so first question, of course, I mean, I want you to work out the voltage, the resistance, and current for everything ultimately in the end. The first question I want to ask is this series or parallel?
It's I think it's series.
Why do you say it's series?
I'm not sure.
So it's a little bit of a trick question, but why do you think it's series? Or is that a purely a guess?
Yes.
So you know how I was saying earlier that these are sort of simple circuits, right?
Yeah.
And you know how I said this is a series circuit and this is a parallel circuit, right?
Yeah.
But I also said that really, you're really looking at whether the components are in series or parallel with each other, right?
Yeah.
So same thing here. So once the circuit gets more complicated, and they almost definitely will, you're not really looking at the circuit as a whole, because this circuit obviously has a serial component. I mean, you have to go through A no matter what, right?
Yeah.
But it has also sort of a parallel component, because here you could go through B or C.
Yeah.
So it's not really, you know, neither answer is really correct. If you say it's series, you're not really right. If you say it's parallel, you're not really right. What is a much better question, but one that's not often asked, is, you know, what you really should be asking is are A and B in series or parallel? So you look at the components, right? So are A and B in series or parallel?
They're in series.
Right. Are A and C in series or parallel?
Also in series, I think.
B and C are in series or parallel?
Parallel.
Yeah, so that would make more sense. That's a better question, okay? But the thing is, of course, if we want to consider this and work out the resistance of A, B, and C, and so forth, what we could often do to simplify the problem is that thing is made up of 2 light bulbs, B and C, right? With different resistances in parallel, right?
Yeah.
But for our purposes, I know what it actually is. But for our purposes, we can think of it like this. So this is still A. Now, this is your yellow thing. I'm replacing that yellow thing with one thing, and I can call it, for example, D. In other words, D represents the whole thing.
Yeah.
Got it?
Yeah.
So you can see, if you think of D as like the whole thing I've put together in yellow as one thing, then it's quite clear that you now have a series circuit. If I think of this as just one thing.
Yeah.
But if you look at this by itself, is this a series or parallel circuit?
Parallel.
Right. So how do I work out the resistance of a parallel circuit?
So it's reciprocal.
Right. So really, D is just a parallel circuit, right?
Yeah.
So I can work out the resistance of D using the formula for a parallel circuit. So remember, that means 1 over the resistance of the circuit, in this case represented by D, is equal to, well, 1 over the resistance of B plus 1 over the resistance of C. And that's 1/6 plus 1/4. And I picked the same numbers as before, just so we don't have to redo the calculations. But that means the resistance of D is 2.4 ohms. Like literally, that's the same calculations we did earlier. Does that make sense?
Yeah.
I kept the numbers the same so I could write more on this page. So that means at this point in time, I've worked out the resistance of D. Does that make sense?
Yeah.
Now, do we know the resistance of A?
Resistance of A. Yes.
What's the resistance of A?
1.2.
So if I know the resistance of A and I know the resistance of D, and thinking about it this way, what's the resistance of the entire circuit?
So it's 2.4 plus 1.2 plus, oh wait, yeah, which equals 3.6.
So if we now have the resistance of the circuit, do we know the voltage of the circuit?
Yes,
What is that?
36.
So what is the current of the circuit?
So current is 36 divided by 3.6.
So at this point in time, we have worked out the voltage, the current, and the resistance of the entire circuit.
Yeah.
All right. But as before, let's go a bit further. All right. Let's say I want to work out all the answers for A. All right. So what is, therefore, let's look at A and D. All right. So for A, do we know its resistance? What is it?
Yeah, 1.2.
Do we know its current?
Yes.
What is it?
Where? No.
What?
Yes. Yeah, like 10.
Yeah. Think about it this way, right? We've worked out the current of this circuit, so that means the current of A must be 10.
Yeah.
All right. So what is the voltage drop across A?
The voltage. Is it also C6?
Well, V equals IR, so
Right. Oh, actually, 12.
now we've worked out for A, its resistance, its current, and its voltage. Does that make sense?
Yes.
Now let's do the same for D. Do we know the resistance for D?
Yes.
What is it?
1.2. Oh, I mean 2.4.
What's the current?
The current is what is 10.
The voltage?
The voltage is 24.
So again, now at this point in time, we have worked out the voltage, the current, and the resistance of everything in this situation, right? So we're saying A has a current of 10 and D has a current of 10, which makes sense because it's series, right?
Yeah.
We're saying A has a voltage of 12 and D has a voltage of 24, which makes sense because 12 plus 24 is 36, right?
Yeah.
And we're saying that the resistance is 1.2 and the resistance is 2.4, and you add them together and the resistance is 3.6. And that makes sense here as well. Does that make sense?
Yeah.
But now, this is D, and D represents this, right? D is this yellow thing, right?
Yeah.
So now, we're saying, therefore, that D has a resistance of 2.4, which makes sense because we added up this in series to get that. We know it has a current of 10, and we've got a voltage of 24. So now let's look at B and C. So B has a resistance of what?
Six.
Yeah, I'll leave off the units because I don't have much space here. Now, can you tell me the voltage of the cross B?
Voltage. It's 6 times wait, sorry, you mean voltage for B?
Yeah.
Okay, so it's 6 times 10.
Well, it's not 6 times 10 because you don't know the current for B yet.
Yes. Oh.
Right? D, you know D has a current of 10, but that is the current for both B and C added together.
Yeah.
But what you do know is that D has a voltage of 24. So D has a voltage of 24, right?
Yeah.
Which means that there's a voltage of 24 across this part.
Oh.
Which means you can know that the voltage across B is 24.
Yeah.
And therefore the current across B will be
4.
And do the same thing for C. What is the resistance?
6.
Resistance for C.
4.
Voltage.
Yeah. 24. So equals 6.
Current.
6.
And that, again, matches everything, right? If this has 6 and this is 4, that makes the total circuit have the 2.4 ohm. If you have current 4 and current 6, that gives you a total current of 10. If you have a voltage of 24, that voltage is 24 and that voltage is 24.
Yeah.
Does that make sense?
Yes.
Yeah, so this is just one simple example of just having the circuits mixed together. Are we clear on that?
Yeah.
Good.